This is the second part of the 8.1 sine, cosine, and tangent for right triangles lesson. In part 1, we were introduced to the three trig ratios, sine, cos, and tan, and we can remember these using the acronym SOHCAHTOA. Each of these ratios represents side lengths on a triangle and how they relate to each other. If we have a right triangle and there's three side lengths, the longest side length is the hypotenuse, and this is the side directly across from the 90-degree angle. The two other sides are either the opposite side or the adjacent side, depending on which angle you're looking at. So we can use these ratios to find missing angles and sides of right triangles. We know the basics of these ratios and how to use them on our calculators. In this lesson, we're going to learn how to solve more complex problems where you're solving for a bunch of missing angles and sides. So some important vocabulary. If you are asked to solve the triangle, that means to find all missing sides and angles of that triangle. You should already know what Pythagoras theorem is. You probably would have learned this in grade 7 or 8. And this is a theorem used to find missing side lengths of a triangle. The equation is this: a squared plus b squared equals c squared, where c represents the hypotenuse and a and b are the other two sides. So for example, if the first two side lengths, if a and b were 2 and 3, let's say, then the relationship is that 2 squared plus 3 squared equals whatever the hypotenuse is squared. So that's how the side lengths relate to each other, and we'll use this to help solve our triangles. And then we have a couple new Greek symbols. You might see symbols that look like this. They're pronounced as alpha, beta, and rho. It doesn't really matter if you remember what they stand for. They're just different Greek symbols that represent unknown angles. I've listed out a couple steps or hints about how we can solve right triangles. The first is that a reminder that the sum of a triangle's angles is 180. So all three angles added up equals 180. And since we're only dealing with right triangles, we know that one of those angles is always 90 degrees. So if you're given another angle, then you can find the missing one by calculating 180 minus 90 minus whatever you're given. So if you have those two side lengths, you can easily find the third one, or angle, sorry. In terms of finding side lengths, if you're given two side lengths, you can find whatever is missing by using Pythagoras theorem, a squared plus b squared equals c squared. But sometimes the problems aren't that simple and we don't have two side lengths or two angles. Sometimes you just might have one of each. And in that situation, we have to use trig ratios to solve for whatever is missing. And I'll go over these examples and details of how we use those trig ratios. But sometimes you also have to use the inverse, whether you're solving for an angle or a side. So we'll start with an easier example. Solve the right triangle. So that means solve for all the missing angles and all the missing sides. We're given a lot of information here, but we have one missing angle here labeled alpha and one missing side length here labeled x. We'll solve the angle first, so the missing angle alpha. Because we're given that one of the angles is 35 degrees and we know the other one's 90, we can easily solve this by using our formula here. 180 minus 90 minus 35 is going to give us that missing angle, which happens to be 55. And we're using this rule here, that the interior angles of the triangle add up to 180 degrees. So that's done. We didn't have to use trig ratios. We found that that's 55. For the missing side length x, we actually also don't have to use trig ratios here because we're given two of the side lengths, making it easy to find the third. We'll use Pythagoras theorem, which is a squared plus b squared equals c squared. We don't know what the hypotenuse is. We're looking for the hypotenuse of x because that's across the 90-degree angle. So a and b can be replaced with the side lengths that we do know, which are 5 and 6. So 5 squared plus 6 squared equals x squared. We're looking for x. This gives us 25 plus 36. That adds to 61. And if we have to get x on its own, remember that the opposite of squaring something is square rooting it. So to get x on its own, we would square root both sides. So x equals the square root of 61. And then you could just put that on directly onto your calculator. And you should round to one decimal place, which should give you about 7.8. So then we're done this problem. We found the two missing pieces, and we were lucky enough that we didn't have to use any trig ratios because we were given so much information. Here's a more complex and more common type of problem that we might see. So same thing, solve the right triangle. we're given an angle and we're given a side, but we have two missing side lengths and one missing angle this time. So we can't use the Pythagoras theorem right away because we only have one side length given to us, not two. So let's find the missing angle first. We have alpha here, and we can solve this using the same way we solved above. 180 minus 90 minus the angle that we're given gives us our missing angle, which happens to be 60. So that's done. We have a bit more information. Next, we need to find those two side lengths. It doesn't really matter which one you start with. I'll just start with x. And if we're trying to find x here, we want to look at the angle that we are given. We're given that this is 30 degrees. So we want to be using our trig ratio here. To decide which trig ratio to use, look at the angle that you're given, 30, and figure out which side lengths or which ratio you have to use so that it encompasses the missing side length and a known side length. So the missing one is x, and from 30 degrees, that's the adjacent side. So we know that we need to either use cos or tan because it has to have adjacent in the ratio. And then the information that we do know is this side length here, 10, which happens to be the hypotenuse. So since we have the hypotenuse and we need the adjacent side, we have to use the cos ratio because that's adjacent over hypotenuse. So we'll set that ratio up, cos of an angle, or theta, equals adjacent over hypotenuse. And then we replace these variables with what we do know. Well, we know that the angle is 30 degrees, so 30 is replaced with, or theta is replaced with 30. We know that the adjacent side is x, which we're solving for, and we know the hypotenuse is 10, so that also subs in there. So we've set up this trig ratio, and we only have one unknown, which is the x. So now we can go ahead and solve by isolating for x. To get x on its own, we would multiply both sides by 10. The 10 comes over here, and then we just put that directly into our calculator. Whatever cos 30 equals, and then multiply that by 10, round to one decimal place, you get about 8.7. So we just found that missing side length using our cos ratio. To find our final side length, our y, you could either use a trig ratio, which I did, or because you now have two side lengths, you could use Pythagoras theorem. I'm going to use the trig ratio. It's usually a good idea to use information that's given in the question as opposed to something you've found during your solution, just in case you've made a mistake. So for example, if I had made a slight mistake in this calculation and then I used it to solve for y, then that would also be wrong. But in the method that I use, the trig ratio, I only use information that was given in the original question. So it just has a little bit less room for error in that case. Okay, so to solve for y, and I have one given angle of 30 degrees. So from this angle, y is the opposite side length. And then the one that I'm given, 10, is the hypotenuse. So if I have if I need opposite and I have hypotenuse, that means it has to be the sine ratio because that includes opposite and hypotenuse. So I set up my ratio. I replace theta with the angle that I have, 30. I replace opposite with y and hypotenuse with 10. And then I solve for y the exact same way I did over here, and I get that it's equal to 5. Okay, another example. Again, solve the right triangle. What is missing here? Well, in this case, we have two missing angles. We have an alpha and a beta. It looks like a little b. Those are both missing, and side length x is missing. So I decided to start by solving for a missing angle, and I decided to solve for beta first. But I've written a note here. You could also have solved for alpha first, and I kind of showed which trig ratio you would use for that. It doesn't matter which angle you solve for first. If I'm solving for beta, from this angle, the two things that I do have are the opposite side length and the hypotenuse. So that means I want to use the sine ratio because it has the opposite and the hypotenuse. I set up my ratio, but this time what I don't know is the angle. And what I do know are the side lengths. So I have sine of beta equals 9/25. Now to solve for beta, to get that on its own, we use what we learned in the last lesson, our inverse ratio. So I would do beta is equal to the inverse of sine of 9/25. You put that onto your calculator, you round to one decimal place, and you get about 21.1 degrees. So when you're solving for an angle, you need to use the inverse ratio, but you still set it up the same way. Okay, so now that we know beta, we can either solve for alpha by starting over with a trig ratio, which you could do right here. Adjacent and hypotenuse is 9/25. Or you can use the information you've already been given and use this simple rule that the angles have to add to 180. So 180 minus 90 minus 21.1, we know that alpha is equal to 68.9 degrees. And then lastly, to solve for the missing angle x, we don't need to use a trig ratio because we have two of the side lengths. We can use our Pythagoras theorem. So we have the hypotenuse of c, and then we have one of the side lengths. It doesn't matter if we replace it with a and b. It does not matter at all. So I replace a with what I was given, and I replace b with what I'm looking for, which is x. So now to solve for x, 25 squared gives me 625. 9 squared is 81, and I brought that to the other side, so we've got minus 81. It gives me 544, and then to solve for that, I would just square root both sides, and I get that the square root of 544 is 23.3. Always round to one decimal place. So now we've solved this triangle because we found the three missing pieces. This is the last and kind of more complex kind of question we could see. Instead of solving for this, we are given two triangles and you want to solve for a specific side length. This is actually the first question from the homework, question 4a. We are given two triangles and we want to solve for side length AB, which is right here. The problem is in this triangle ABD, we don't have enough information to solve for that right now. All we're given is this angle and of course a 90 degree. So yeah, we could find this angle, but we'd have none of the side lengths. So we aren't able to solve for that side length because we don't have any of them. But the good news is that this triangle is attached to this other smaller triangle, and they both share this side length AD. The smaller triangle does have enough information to solve for a side length because it has this and this. So we can use the information given to find the angle or to find the side length AD, which they share. And then once we have this side length and this angle, we can solve for what we're actually looking for, which is AB. So you have to be able to identify, this is what I don't have so far, but this other piece of information in this other shape, we can solve for this, and they share these pieces. So first we would find missing side length AD. From the angle 28, we have the opposite side length, and we need the hypotenuse. So we have to use the sine ratio. We replace theta with 28, we replace opposite with 6, and we're solving for the hypotenuse, which is AD. To get AD on its own, you're going to cross multiply. So the AD and the sine 28 just switch positions. And then we put this onto our calculator, 6 divided by sine 28. Rounding to one decimal place gives us 12.8 millimeters. Now that we know that this is 12.8, we can solve for our missing side length. So from the angle 36, we have the adjacent side, we just found that, and we need the hypotenuse. Adjacent and hypotenuse gives us the cos ratio. We replace theta with what we know to be 36, that angle is 36. Adjacent is 12.8, we just found that, and we're looking for the hypotenuse AB. To get AB on its own, we cross multiply, so these switch places. We put this on our calculator, and we get 15.8 millimeters when we round to one decimal place. So now we've solved for the side length we know, or we wanted. So this is how we use our trig ratios and other information about triangles to solve for missing angles and missing side lengths.